There's a pattern buried in almost every real number in finance, stock prices, tax filings, expense reports. Nobody put it there on purpose. And when someone fakes their numbers, they almost always break it without realizing. Take any number. 1,240. 87. 3.4 million. The leading digit is just the first digit you read. So here's a question. Grab a random number from the real financial world. What's the chance it starts with a 1? Most people say about 1 in 9. Just over 11%, same as every other digit. Sounds fair, right? Now pull first digits from something real. Every country's population. Every price on the S&P 500. Thousands of company expense lines. The fair guess falls apart. The digits are nowhere close to equal. The number 1 shows up almost a third of the time. The number 9 shows up less than 5%. Every single time, on almost any real dataset. This isn't a coincidence, and it isn't magic. It's a formula, discovered by Frank Benford in 1938. The chance a number starts with digit d is log base 10 of 1 plus 1 over d a plug-in 1, and log 10 of 2 is 0.301. That's 30.1%. Plug in 9, and log 10 of 1.111 is only 0.046. That's 4.6%, exactly the curve we just saw. Here's the intuition. Think of every number sliding along a scale from 1 up to 10, then repeating 10 to 100, and so on. To go from a leading 1 to a leading 2, a number has to double. That's a huge stretch of the scale. Digit 1 owns a wide slice of the line. But to go from a leading 9 to rolling over to 10, it only has to grow by about 11%. Digit 9 owns a tiny sliver. Any number that grows by compounding prices, revenue, populations spends far more of its life starting with a small digit. This is exactly why finance is Benford's natural home. Revenue figures. Transaction amounts. Tax filings. Stock returns. Anything that grows naturally, across many orders of magnitude, quietly obeys this law whether anyone is watching or not. Which means honest financial data should follow the curve. And invented data almost never does, because humans are bad at faking randomness. So here's exactly how a forensic accountant runs the test. 4 steps. Step 1, pull every number, every expense line, every invoice, every reported transaction. Step 2, strip each one down to just its first digit. Step 3, count how often each digit leads, and build the observed curve from real data. Step 4, lay that curve against Benford's curve and score the gap. A small gap is normal. A big one means, look closer. Here's a company's reported numbers, digit by digit. The dashed marks are what Benford's law expects. Watch the bars. Digit 1 is far too rare. Digits 5 and 6 are wildly overrepresented. Almost nobody's real data looks like this. This exact method has flagged Enron's cooked books, faked expense reports, and even suspiciously rounded election vote counts. But this test doesn't prove guilt on its own, so use it with care. It only works on natural, wide-ranging data, not on things like phone numbers or lottery draws, which are assigned, not grown. And it needs volume. A handful of numbers can look strange purely by chance, the pattern only emerges at scale. So next time someone says, the numbers don't lie, remember, the first digit almost never does either. Fabricate a figure, and you leave a fingerprint that math can see.